Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be understanding the concept of moment of inertia, and you are going to understand the differences between the area moment of inertia and mass moment of inertia. And let us look at the concept of moment of inertia. Here, moment of inertia is a quantitative estimate of relative distribution of area and mass. That means you are going to calculate a quantitative value, a numerical value, which is relative distribution of area in case of area moment of inertia, and you are going to consider mass in case of mass moment of inertia. And here area moment of inertia is connected with two-dimensional, that means it is applicable to plane areas only, and whereas the mass moment of inertia is connected with three-dimensional objects. And 2D and 3D area moment of inertia is connected with two-dimensional, that is plane areas, and mass moment of inertia is connected with three-dimensional objects. Now let us look at the differences between area moment of inertia and mass moment of inertia. The very first point is the definition of area moment of inertia. It is the moment of area, and we call it as even second moment of area. That means RDA is moment of area, and RDA of RDA is R square dA. So that value is nothing but your area moment of inertia. The other side, let us look at that. It is the resistance offered by the body for the rotation. So you are going to calculate the resistance when a body is about to rotate. That means here this particular area moment of inertia is concerned, it is connected with the statics part of it. Whereas in mass moment of inertia, the body is rotating about the reference axis, and when it rotates, the resistance offered by the body for the angular motion or rotation is that is mass moment of inertia, and the formula is integral r square dm. You can observe clearly r square dA, r square dm. So these are the formulas, and you can see that I is the symbol for the moment of inertia, which is common for area moment of inertia and even mass moment of inertia. Here I is the symbol used for area moment of inertia as well as mass moment of inertia. Let us look at the second point. It measures resistance to the bending. That means when it is a statics part of it, and when load is acting on a beam, let us consider this is a beam. Assume that it is a beam. The scale, I have taken steel scale, and when the load is applied, it is going to bend. You can observe that it is bending, right? And it is going to offer resistance for the bending. That's what is your moment of inertia. And this orientation, you can observe that it is bending. But when you change the orientation, now I am trying to bend it, it cannot bend. That means the resistance for the bending is increased with this orientation. So that's what exactly you're going to learn, and you're going to calculate that it's a measure of resistance to bending. So the resistance offered by the body for the bending moment or bending is called area moment of inertia. Whereas the other side, let us look at that, it measures the resistance to the rotation. When a body is rotating, let us consider this wheel is rotating, and it offers resistance to the rotation, and that particular resistance is called mass moment of inertia. And lastly, you can see that here the units used for area moment of inertia is meter to the power 4. That is the other side, it is kg meter square. The units are, it is meter to the power 4, and here it is kg meter square. And the third point is area moment of inertia is useful. So where we are going to use in strength of materials, as just now we have seen that it is going to, you are going to calculate the resistance offered by the bending, and in bending equation you are going to calculate the section modulus using this particular bending resistance, and it is used in design of beams and structures also. The strength of materials concept and this particular concept, you know Mainly the applications are concerned, you're going to use to design beams and structures also. The other side, let us look at that. Here, mass moment of inertia is useful in dynamics of rigid bodies. When a body is a rigid body is rotating, the dynamics of rotation you are going to consider, and mainly whatever you are connected with the rotating bodies, maybe gears, maybe flywheels or gearboxes, in which you'll come across with the various rotating elements. To design that, you are going to consider the mass moment of inertia. I hope you understood the concept very clearly, the differences between area moment of inertia and mass moment of inertia. Thank you very much for watching this video.